All right, so this is another indeterminate form. Remember, the indeterminate form here, 0 times infinity, it's indeterminate because we have two rules going on here that conflict each other. 0 times anything is 0. Anything times infinity is infinity. So we have, like I said, two conflicting rules. And so this turns out to be an indeterminate form. You okay? All right, so as x approaches infinity, that's going to be infinity. The sign of 1 over x is the same thing as the sign of 0. Everybody see why? 1 divided by infinity is going to be 0, so the sign of 0 is going to go to 0. So we have infinity times 0. That is an indeterminate form, but it's not an indeterminate form that works with L'Hopital's rule. L'Hopital's rule requires that we have a numerator and a denominator. So what we're going to do is we're going to rewrite it. What I'm going to do here is rewrite it as the limit as x approaches infinity of the sine of 1 over x over 1 over x. Now we didn't do it this way last time we did this problem, but this is going to work for us. It's going to be a little bit more complicated though, at least more complicated than the problem was after we did the substitution. So if we confirm this here, first of all, does everybody agree this right here is the same thing as x times the sine of 1 over x? If we divide by 1 over x, it's the same thing as multiplying by x. So we know that the sine of 1 over x goes to 0, but we also know 1 over x goes to 0. So now it's in a form that L'Hopital's rule is going to work. And since we have that indeterminate form, we can take the derivative. The derivative of sine of 1 over x, we're going to have to use the chain rule, and we get negative 1 over x squared times the cosine of 1 over x all over negative 1 over x squared. What can we do with those negative 1 over x squareds? Yeah, those cancel each other out. And so what we have is the cosine of 1 over infinity, which is the same as the cosine of 0, and the cosine of 0 is 1. Now, we did this another way. So another way we could do this is by using substitution and saying that 1 over x is going to be u, which means then that x is going to be 1 over u. And if we replace everything here, the trickiest part is figuring out what u is going to approach. So as x approaches infinity in this equation right here, what does u approach? It approaches 0, but we said it's important, or it could be important to know which side it approaches 0 from. So since x is going to be positive infinity, then u is going to be approaching 0 from the right. So we can rewrite this then as a limit as u approaches 0 from the right of, well, the x here is going to become 1 over u, and then the sine of 1 over x is going to be the sine of u. And then this turns into a problem that we've already done. We use L'Hopital's rule here. Because it's 0 over 0, we take the derivative, cosine of u over 1, plug in 0, and we get cosine of 0, which is 1. We get the same answer. This problem, once we do the substitution, might be a little bit easier because we had to use the chain rule here, but either way is going to work.